Can I get a show of hands? Who here has ever used Puppet? Ever? Wow, that's a lot more of the room than I expected, to be honest. How many of you have used Puppet but at one point or another, but stopped using it for some reason or other? Okay, a few of you. I'll be honest, I'm really aiming this at you people. So, and so I take it the rest of the room hasn't ever tried Puppet, so hopefully I give you some reasons to want to try it. So, just to set a baseline, what is Puppet? So Puppet is, first of all, a configuration management tool. So what that means is Puppet will manage things like the state of packages, services, other kinds of resources. It's implemented as a Ruby-based DSL, domain-specific language. So it looks like a programming language, and it does stuff. So it's a declarative language, which is one of the interesting things about it. You actually you model your desired state in the Puppet language. So what you're doing is you're defining an end state, not necessarily steps that it takes to get to that end state. So, you know, when you think of in terms of like writing a script, it's like, oh, I need to install this package, and then I need to, you know, make sure the contents of this file have this line or something like that, and then I need to start up this service, and maybe I need to, you know, mark that service to come up on boot. So in Puppet, what you're going to do is you're going to say, I want this package to be installed. I want this file to be here, have these permissions, and have these contents. I need this service to be running and set to enable on, and set it enabled on boot, right? And the first time you run it, if none of those things match, well, Puppet's going to make a match. The next time you run it, Puppet's going to make sure that those things are all there, and, you know, make sure they all match. If somebody goes in and messes up that file, the next time Puppet runs, it's going to fix that file. If somebody stops that service, the next time Puppet runs, it's going to start that service back up, right? So like I say, you're modeling that desired state. Puppet is also agent-based. It runs every half hour by default. So if you install the Puppet agent and start up the Puppet service that creates on the system, then every half hour it's going to wake up and it's going to run. And so that enforces your desired state. Okay? Make sense? All right. So, but Puppet's weird. Okay, so I'm not going to lie. There are some things about it that make it a little bit difficult to learn. First of all, that whole declarative language thing is a little weird because again, you're not writing, you know, do this, then this, then this, then this. You're just saying, I want this. Now you might say, in order for this to work, this other thing has to be there first. So you can put some ordering in the language, but you don't have to. Yeah, so that's weird. Speaking of ordering, it can execute out of order. So just because you went top down with something, you know, it's like, okay, I want to do this, I want to do this, I want to do this. That's not necessarily the way Puppet's going to actually do those things. It's going to figure out dependencies, and it's going to rearrange things based on a directed cyclic graph, I think it uses. So that's a little weird. So in the language itself, one of the weird things is variables are constants. You can set them once. So that makes a lot of things weird, you know, when you're thinking in terms of writing language. But when you think about it in terms of the fact that things can be out of order, it starts to make sense. You get a value for that variable once, then Puppet can use that variable anywhere else in the code, right? So it just has to make sure that whatever needed to evaluate to get that variable happened before it tries to determine what to do with that variable. Code actually compiles to a catalog. The code doesn't like execute directly. The way that it works, even if normally if you run a master agent kind of a thing, the code lives on the master, compiles on the master, compiles to what they call catalog. It's basically a big blob of JSON. That gets shipped over to the agent. The agent then iterates over the catalog in order to actually enforce configuration. If you run Puppet just on a system, you know, just do a Puppet apply, blah, 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 then Puppet still compiles a catalog and applies it locally, right? So that's a weird thing. Another weird thing is you don't actually run Puppet code directly, generally speaking. What you do is you write classes, and then classes get assigned to nodes, which is one of the ways that Puppet scales like fantastically. You just basically say, okay, these nodes have this classification, these nodes have this classification, you know, so on and so forth, and everything just works. But it's a thing that takes a little bit to wrap your brain around. On the kind of tooling side of this, if you run a master agent kind of thing, there used to be this passenger rack thing or a WebRick based Puppet master way back in the day, and anymore there's a Java based Puppet master which actually uses JRuby, because again Puppet's all based on Ruby, so that's a little weird, because you end up having to do some, you might have to do some Java tuning stuff, but yet it's actually running Ruby code, so that whole thing's just a little bizarre. And then there's another piece called PuppetDB that lets Puppet store information about runs and things. It's useful but not required. It's also Java based, although oddly enough not written in Ruby or in Java. So that one's a little strange. So anyway, that's probably not a complete list of reasons why Puppet's kind of weird, but I just wanted to throw those things out there. All right, so Puppet's been around for a pretty long time. Luke, by all accounts, I'm getting most of this from looking at old mailing list posts and some stuff on Wikipedia, but I wasn't around. Well, I was around. I just wasn't doing Puppet at the time. But development looks like it began somewhere around 2005. Somewhere around 2008 was when the first public releases came out. The first release announcements that I could find were from 2009, but those were versions that I know weren't the first versions, so I don't know where the release notes are for those early versions. The first commercial release, the first release that Puppet did as a company of Puppet Enterprise, or what's now Puppet Enterprise anyway, was in 2011. So, it's definitely been around for a bit. But the part that I care about personally is what I'm going to call the modern era of Puppet, okay? This started with the release of Puppet 4. Puppet 4 was a pretty dramatic shift in the language, made a lot of changes. It was a pretty dramatic shift in a lot of the tooling, too. That happened in April of 2015. And then there continued to be some things shaken out for the next couple of years until about Puppet 4.10. So really, if you've used Puppet but anything before 4.10, then you weren't using what I would call modern Puppet. Okay. So just to give you an idea, and that was only April of 2017. So we're only talking 2.5 years ago, right? So. All right, so let's talk about some things that changed with this modern era of Puppet. First of all, the packaging from Puppet. They started using what they started calling all-in-one packaging. I noticed that the AIO thing has kind of disappeared from most of the documentation these days, but the general idea hasn't changed. Instead of just having like a Puppet package that would pull in like system Ruby and system OpenSSL and a bunch of other stuff, basically Puppet started building all of that into the Puppet agent package. So the version of Ruby that works with that version of Puppet is bundled in. You don't have to have a system Ruby for it to work. Most, not all, but most of the OS dependencies are all contained in that one package. That way, if you install a Puppet agent on, RHEL 5, then, it's going to work just as well as it does on RHEL 8. Because I can guarantee you that the system Ruby is way different on those two. All right, so speaking of Ruby, when you're actually developing Puppet, you have to do far less Ruby now than you used to. It used to be that you could do a lot of stuff, in the Puppet DSL, but if you wanted to extend it pretty much at all, you had to dip out to writing things in Ruby, which is a little bit of a, it's a little bit of a shift. One of the big places where you'd have to do that is templates. Puppet would use embedded Ruby templates. Okay. Well, now there's a file format called EPP, embedded Puppet, that looks an awful lot like ERB. Same kind of tags and stuff. A lot of the same things. Actually takes parameters though, which is kind of cool. And in line, when you put code in a template, it actually uses the Puppet DSL. So you don't have to learn 2 languages in order to do the thing. Also, there's native Puppet functions now. Used to be that if you wanted to have a function that did some random thing, you would have to write it in Ruby. And now you can write functions in the Puppet language itself, which is pretty cool. Okay, so next thing, native iteration. So it used to be that Puppet had before the modern era, Puppet had a concept of things like arrays and hashes, but you couldn't iterate over them, or you couldn't really do much of anything with them in the language itself. You could pass them off to Ruby functions, or you could use them in embedded Ruby templates, and you could iterate over them and stuff in Ruby, but you couldn't do it in the Puppet language itself. So in Puppet 4, that was fixed. So any of you that did Puppet back in the day, you may have done, there's a function called create resources. You could basically pass it a hash of, tell it a resource type, pass it a hash of titles and parameters or attributes for those resources, and it would create all those in the catalog, right? Well, you can do that natively in the DSL now. So if we have a hash named $packages, we can do .each. You'll note this looks an awful lot like how you iterate in Ruby, except that instead of having do and then the pipes, you have the pipes and then the curly braces. So it's Ruby-ish, just not quite. But anyway, I can say, okay, I'm gonna take every string and every value. I'm gonna say each one of those things is gonna be a package. That's gonna be the package name, and any attributes, we're just gonna expand those out, like we put those in line, right? But this also means that in here you could add extra stuff or modify those values. If you wanted to do some some manipulation on those things. So native iteration is a good thing. Strong typing. So in early versions of Puppet, everything was a string. Everything was a string. However you used it, it was still a string. It would, you could do math on strings and it would do the right thing, things like that. But ultimately, everything was a string. So now Puppet supports data types that are at least roughly equivalent to underlying Ruby types. So, you've got things like string, array, hash, Boolean. There's numeric types, integer and float, and all sorts of things like that. There's actually a whole bunch of data types, and some of the things that you can do with some of the data types are kind of fun. But this completely eliminates the need for a whole class of functions that were in the Puppet Lab standard lib that would validate inputs to classes. It's like, I got this variable, but it could be a string, it could be a hash, it could be a number, I don't know, but I need it to be an array, right? So you'd have to start every class with validate underscore array, validate underscore hash, and you'd end up writing all this validation logic before you actually did anything, right? Now you don't have to. You just declare the parameters as the appropriate data type, done. So it simplifies code substantially. We also then have structured facts, which is kind of a cool thing. So if you don't know Puppet, one of the core things in Puppet is this thing called facts. And facts are just bits of information about a system, right? So could be the host name, could be the architecture, could be the OS name, things like that, right? So it used to be all facts were strings. Even if the fact contained like a list of things, it would give you a string of comma-separated values, right? And so you would have to you would have to jump through all kinds of hoops in order to be able to do anything useful with that, right? Well, now, if a thing is supposed to, instead of a string of comma separated values, which, by the way, with native iteration, we could just split and iterate over if we wanted to, but instead, we'll actually get a fact that is an array. It used to be like there was a operating system mage release fact. And that, but now we can actually say, oh, I want the fact that is OS release major, right? And just use it as a hash. So that's just one example. Okay, so Hira is a thing that was introduced somewhere in the Puppet 3, I think, time frame. Don't remember exactly when. But basically what it is it's a key value store kind of a thing that you can use as a data layer for your Puppet code. Okay, and the reason it's called Hira is because the way it uses a hierarchy of values. It's generally YAML files. You can use JSON. You can use other things. It has a pluggable backend and whatnot. But anyway, the format of Hira changed in version 5, which is the thing that came in Puppet 4.10. So Hira v5 lets you do, you could always have like a hierarchy for the whole system, but doing like per Puppet environment hierarchies was difficult. So now not only can you do per environment hierarchies, but you can also do Hira in modules, so you can have per module hierarchies. And so there's lots of ways to get your data plugged in. And then another cool thing is there's a key, a reserved key called lookup_options that you can put in Hira to define like merge behavior. So if you've got all these layers of Hira, normally the way that works is the first match will win. But you can turn on merge behaviors where you can say, okay, this is an array, just mash all these together, but give me all the unique values. Or you can say, for hashes, I want to deep merge all of those, any results that I get, and get all those results back. So now you can put that in Hira instead of having to explicitly call the lookup function with all these things to tell it, merge strategy and whatever else. And the reason why that matters is because there's this thing called automatic parameter lookup. Now this isn't a new thing in Puppet, but I honestly think that people don't. Well, it's hard to understand, and it's things that people don't use nearly to its full extent. So the way this works is I've got this class named myClass, and I've got a parameter named $parameter, right? So Puppet is going to look in Hira for a key called myClass : parameter, and it's just going to automatically drop that in to this class as this $parameter. Okay. So if that were a hash, somewhere in Hira I can say lookup options and merge strategy deep and tell it to deep merge that. And so the automatic parameter lookup just works. In older versions of Puppet, you would have to do things like you'd have to set this, you'd have to say string $parameter equal, and then you'd have to do the function call in order to get the data back in that deep merged state. Okay, so another thing that's cool, because now we have all this cool stuff that we can do, and it's so much easier to write modules, that now the Puppet Forge is so much better than it used to be. When I got started, it really wasn't that long ago, most of the modules on the Puppet Forge were like maybe okay examples of, like I'd go look at somebody's code and try to figure out how they implemented a thing, but I would almost never just go grab it and use the modules. The quality just wasn't there. They weren't configurable. There were just a whole lot of reasons why the modules off the Forge weren't awesome. But nowadays, if you go to the forge.puppet.com, you can find modules to do just about anything. So honestly, if you want to use Puppet, in a lot of cases, you don't really have to write a whole lot of code. You can just go grab other people's modules and just make sure that you're getting your classification right, and everything will, maybe add some parameters to, some hierarchy data for some of those modules, and you're set. Okay. All right. If any of you used Puppet Enterprise, a few years ago, you probably had some exposure to this thing called mCollective. Personally, I was a big fan of mCollective. mCollective would let you do things like trigger Puppet runs, start and stop services on things on a kind of an ad hoc basis, that sort of thing. That actually got pulled out of Puppet Enterprise completely. Puppet Enterprise now uses this thing called PXP in order to control the agents remotely. It's a small subset of the functionality that mCollective had, but they completely ripped mCollective out. But that's okay, because if you like mCollective, the guy that wrote it originally has started a project called Coria, Coria.io. Makes it a lot easier to install mCollective. He's actively maintaining it, and it includes pretty much all the old mCollective functionality. Plus, he's added a bunch of stuff. So, like I say, you don't have to use mCollective if you don't want to, but it is still around. All right. So then, the way that Puppet works, where you're just defining an end state and everything, is great for maintaining like a baseline OS. It's really great for compliance, which, by the way, I work for a company that does an automated compliance tool that's open source, that's based on Puppet, and I have t-shirts for that if anyone wants one. Yeah, one of those t-shirts. Anyway, but that said, there are times where what you need to do is just trigger an action, right? Completely outside of the the normal baseline stuff that Puppet does. So this is actually why a few years ago I was, people were like, trying to do an Ansible versus Puppet kind of a thing. I'm like, they're not really the same. They don't live in the same space. You can set up Puppet for maintaining a baseline and use Ansible in order to trigger a deployment or something like that. Things that are specifically timed one-off kinds of tasks, right? Well, Puppet listened to their customers. Their customers wanted this, right? So they came up with this tool called Bolt, and they came up with tasks and plans. So what tasks are scripts that can be written in any language, as long as an interpreter is available on the system where you're trying to run it. And then they have some structured metadata that defines parameters and whatnot. Plans are written in the Puppet language, and they can be used to drive other plans, tasks, and blocks of Puppet code and various other things. And then, like say, Bolt is the tool that is used to run all these things. It supports SSH, WMI, has a local transport, so you can use it on a local system, and it's got a whole plugin interface thing. Also, it can use that PXP agent that I mentioned before in order to trigger tasks. So anyway, this has the cool side effect that because you can actually execute blocks of Puppet code using a plan, you can build your Puppet code to maintain a baseline. But if you need to, start up a cluster that has to come, where nodes have to come up in a specific order, rather than having to write complicated logic in your Puppet code to only start a service if this other thing is listening or something like that. That stuff that's all kind of crazy complicated to do in native Puppet. You can just write a script that does as a plan that does this thing, then this thing, then this thing, and you can actually have it just apply a specific class to a specific set of nodes. When that's done, apply a class to another set of nodes, and then you can let the Puppet agent just maintain all that going forward. So if something gets stopped, it'll get restarted, that sort of thing, right? So it's a really cool thing that works really nicely with Puppet. So, if you're writing Puppet code, one of the cool things that we have now is a thing called the Puppet Development Kit, PDK. So this is used to generate new modules and actually keep the modules going, work with their whole life cycle. It includes templates for building Puppet modules, classes, define types, a whole bunch of other things. It includes tools for checking syntax and style of Puppet code, module metadata, YAML data, so on and so forth. And most importantly, for the same reason that the Puppet agent bundles its own Ruby, PDK bundles its own Ruby, so that and all the gems that are needed to do all that stuff. So you don't have to worry about when you install PDK, you don't have to worry about then having the right system Ruby version or mess with RVM or any of that kind of stuff. So I'm going to do a quick demo, if the demo gods will have it. Can everybody see that okay? All right, so I'm going to do PDK new module, and I'm going to do my initials as the author, and we're going to do PDK demo. Ignore some of that crap. My Ruby environment seems to be a mess at the moment, but anyway, the part we care about is down here at the bottom. So you have a Puppet Forge username, add it here. Let's pretend that's true. Let's add that. We're going to say this is Apache 2.0. And then I don't really like Windows, so I'm not going to support Windows, but I like Fedora, so I'm going to add Fedora in. So this is the OSs we're going to say are supported. Hit enter. Module metadata will be generated based on this information. Yes. And outspits a new module called PDK demo. All right. So this all just gets created for you, okay? And so this is basically just an empty module that you can put things in. If we look at the metadata.json, it's all that stuff that we just answered, and it does this all for you. So now if we say PDK new class, and we're going to make a class the same name as the module. Again, please ignore all the ignoring lines. I forgot to fix that before I came in here. But the two lines at the bottom there are the ones that we care about. It created manifest init.pp, and then it also created a test for it. Okay? So if we look at vim manifest init.pp, it created an empty class, including documentation that can get pulled out using Puppet strings, and we can just go from there. So we do our editing, and we say I'm going to do because I'm unimaginative. And I'm going to say I'm going to put this in here. And so we do that, and then we say PDK validate, and it's going to do syntax checking and whatnot for us. And if we look, I got a warning. Everything passed, but it did give me a warning that there's an optional parameter listed before required parameters. Okay, I did that on purpose. I knew what I was doing. Because that is so weird. Oh yeah, and if I'd written this out, Vim would have told me the same thing. So if I change the order of those around, and then PDK validate again, then it'll come up clean. And so all of our syntax is checked and everything else. If we do PDK test unit, it'll actually run the RSpec test, which by default what gets generated is just a test that tests that the code compiles, and that's it. So you can certainly do more, but oh, look, it failed. Okay, I don't even know why. But let's see here. Usually you end up having to scroll back a bit. Oh yeah, because I had a required parameter and I didn't specify that as a parameter, so it blew up just like I expected it to. I just had already forgotten that I expected it to do that. Anyway, so but you get the idea. You can sit here, lather, rinse, repeat. So that's the first big thing that we've got for development tools. Second big thing. All right, I'm going to tell you honestly, as an old school Linux guy, it hurts my soul to say nice things about Microsoft, but I have to, okay? If you have not worked with Visual Studio Code, you really must. It is a very nice editor. I say this as a Vim guy, okay? But also I'll tell you there's a really nice Vim plugin that makes it pretty usable as a Vim person. The reason why I'm mentioning this now is there is a Puppet plugin. The URL is down at the bottom there that actually integrates VS Code with PDK. So if you've got PDK installed, it'll let you write in VS Code, do all the stuff that I was just showing you from the command line. It turns VS Code into a Puppet IDE basically with, things like autocomplete, and you can, hover over a thing and you can see, information about like, what does this thing do and whatnot. And then, yeah, what are we showing here? Just an example. Okay. Yeah, anyway, so like I say, you got syntax highlighting and all this kind of fun stuff, right? So anyway, VS Code, very nice. Like I say, just search on the extensions for Puppet. I'm sure you'll find that one. And while you're at it, there's a few others that I usually recommend, like Ruby and like I say, that Vim one is pretty good. So yeah, it's much easier to develop Puppet code than it used to be. All right, so now I have 15 minutes. I want to show you an example of what a modern Git workflow might look like. This is going to be a little bit of a contrived demo, and I apologize, but all right. So what I have here is I have Puppet Enterprise. This will work with open source Puppet. A little easier to get working with Puppet Enterprise, but so what I have here is a really small environment. I have the Puppet server, and I also have a GitLab server, and I have an agent node. So the agent node, if I switch over to that and make that window much larger. This has an external fact defined for the role of this system. I'm saying that this system is going to be a web server, and that's just a string that I put in there. Means nothing except if we go into our hire.yaml. Probably need to make that a little bigger too. All right, so my hierarchy is I'm looking at the cert name, so the host name of the box, and then I'm going to look most specific to least specific. I'm going to look at the host name of the box, then I'm going to look at the role, and then I'm going to look at this common file. So in my data, I have a roles webserver.yaml, and in this, I'm using the classes array to define what classes I want to apply. So I'm not adding any at this level, okay? But I want it to be a web server, right? So I want it to run Apache, okay? So what I'm going to do, I have what I need over here, so I can copy and paste. Whoops. All right. I'm going to go into this file called Puppet file, which lists my modules. And I'm going to change that, and I'm going to add Puppet Labs Apache and this Puppet Labs concat, which is required by the Apache module. Okay. So this file tells the Puppet Enterprise Code Manager, which is based on this tool called R10K that you would use if you were using open source Puppet. Tells it what modules that you want to install from the Puppet Forge. You know what I did? I forgot to make sure that I can actually get to the internet. I should probably double check that. That's old. Can I get out to the internet? Sorry, the one thing I forgot that I needed to double check when I got in here.
There are two Wi-Fi networks supplied by the hotel, Hyatt MR, which I
Yeah.
able to get work.
Oh, I'm on Hyatt Wi-Fi, so yeah, I need to switch over to the Hyatt MR.
This is the one that works.
The MR one runs a little faster, right?
It also requires code.
Yeah, but I've got the code.
Oh.
Yeah. Hang on one second. I'm so sorry. So that Puppet file that I was showing, it's going to pull those modules from the Puppet Forge. Okay, it didn't prompt me to log in, so I guess I'm okay. All right. So anyway, which means that I have to be able to get to the Puppet Forge, right? So I'm running Vagrant on my local box here for all these VMs. So I need the VMs to be able to get out to the internet. So that's why I needed to test that. So all right. So now we're going to have the Apache module available. So now I just need to go back to my webserver.yaml and say I'm just going to tell it that I want the Apache class applied. Okay. And you'd have to do some configuration and stuff, but I'm just going to skip over all that for right now. And I'm going to commit this. So I made a couple changes here, whatever else. But I'm going to create a new branch, and we're going to call this web server because I am unimaginative, and we're going to start a merge request. So we're going to commit that. Now, what is going on in the background there is I've created a branch in GitLab that's going to trigger the Puppet Enterprise Code Manager to now deploy a new Puppet environment named Web Server. Normally, if you're doing this in GitLab, you're going to set this up so it'll do testing. You're going to have your GitLab runners run tests and whatever else, and you probably won't be able to merge this request until all those tests pass. I don't have any of that set up, so we're just going to hand wave and pretend all that happened. Okay. So I'm going to submit this merge request. But in the meantime, if I go over to my agent, actually, you know what? Let's just double check that Etsy Puppet Labs code environments. There's a web server environment now, and things are deployed there, so that means that worked. So now, if we go back to our agent, I can do puppet agent -t -- no op because I just want to see what's going to happen. and I'm going to say -- environment web server. So now, yep, I didn't get agent specified environment working correctly. I thought I did. I thought I had that working ahead of time. All right, so take my word for it. If you've got this set up right, this is forcing it into the production environment. But I'm running out of time, so I don't have time to fix this. But take my word for it. What would normally happen is it would tell you, I'm going to do all this stuff, and it won't actually make any changes with that -- no op setting. So anyway, once you've done some canary testing, maybe actually applied to some nodes, right? Then you go back, you hit merge. I'm going to hit delete source branch, merge, and again, you might have this all set up so it runs a pipeline in the background, does some tests and stuff before it actually triggers the deployment of the code. But once that's done, what actually happens on the Puppet server is that other environment will go away. So we'll give that a second. Come on, there it is. All right. So now that's deployed. So if I go over here and I just run this against the production environment, now it should do all the things that I was wanting it to do the last time. Now that's just it doing some file sync stuff, so ignore all that. I upgraded a couple of modules while I was at it. Blah, blah, blah. Do stuff. All right, so we're loading facts. And the next thing you know, it's going to spit out how it would install Apache and set up some files and whatever else. And you notice it says, would have whatever, would have, so on and so forth. So that all looks good, so I'm going to do it for real. I could wait. The agent would eventually wake up on this thing and it would just do it for me, right? But it's way more interesting to watch it, so that's why we're watching it. But if I imagine I had a whole fleet of systems that all thought that they were supposed to be web servers, right? I've gone and made this change within a half hour. They're all going to be configured. It may be trying to actually install a package, and the internet might not be terribly fast, so this may actually take a little while. Oh, no, there it goes. All right, only took 32 seconds. That's not too bad. So now this thing is a web server, right? Just like that. Obviously a web server that doesn't do a whole lot, but you get the idea. Okay, so in our last couple of minutes here, let's ask a hard question. Is Puppet still relevant? Okay, I have a lot of people that'll tell me, oh, I don't care about Puppet. Puppet manages systems. I'm doing everything with containers. So if it's not Kubernetes, I don't care, right? And those people are not 100% wrong. But the thing is, while containers are great, full systems are not going anywhere anytime soon. It may be that if you're doing on-prem Kubernetes, something has to actually run that Kubernetes cluster, right? And the thing is, both containers and Puppet provide immutable infrastructure, just in a different way, right? I am not trying to make a value statement on which one's better than the other, but they both are valid approaches. Enforcing system configuration with Puppet is great for compliance. And again, I work for a company that does a compliance tool. There's a reason we use Puppet for that. In highly regulated environments, containers usually aren't an option yet. Eventually the compliance standards will catch up, and people will be able to do containers. But it's not containers are not a solution for everyone for every application, right? So systems are just not going anywhere anytime soon. And then, like say, the combination of Bolt and Puppet can cover one-off tasks and ongoing enforcement with a common code base, which is pretty awesome. So why adopt Puppet now? Funny side story. I was like, I feel like I need a little bit of something to finish this off, and so I threw this out on my work Slack, and Trevor, one of the guys that owns the company that wrote the compliance tool, and been one of the oldest Puppet people on the planet, he gave me this list, and I'm like, I love it. I'm putting it in right, just verbatim. So, Puppet puts guardrails around infrastructure as code. Puppet allows for full state introspection prior to application for advanced users. Like say, in other words, you can do testing. You can model your environment and you can test that it's going to do the thing that you want it to do. The language has hit stability. It's unlikely to have major breaking changes moving forward. We're on Puppet 6 now, and basically nothing of any, nothing substantial has changed. It's just been additions for the most part since Puppet 4.10. And the language flexes easily between users that don't want to program. Those people are usually just going to make changes in YAML files for Hira, and those that do without alienating either one, right? So, questions? Yes?
Object naming. We're still on Puppet 3. We have the issue where I'm doing, let's say I want to add a line to Etsy posts.
Right.
I have one module that I want to add something, and another module that wants to add something different. And those object names, you can't just use Etsy posts.
Resources can only be in the catalog once, period. So they can't be redefined. So there's ways around that. There's
Just making up stuff. Is
um,
there a better way?
well, generally, if you've got multiple modules that all want to manage a different thing within Etsy hosts, what you do is you use there's a hosts resource, and you just say I want this host. And so you only manage, what you end up doing is managing an individual line of the file instead of managing the whole file. So there's a lot of that where, the unit, the resource, the unit thing that is managed by Puppet might not be as, or it's probably more fine-grained than what you might immediately think. It's like, I want to manage Etsy hosts. Well, no, what you want to do is you want to manage each record in Etsy hosts, right? Does that make sense?
Maybe it's just a module we haven't dug really much in the modules. We're using file line.
Okay.
What we're using to do that, and so maybe what you're saying is the host module.
Yeah, so it sounds like if you're using file line, you're probably doing it the right way. Your issue is, like you said, you're just calling your resource Etsy host, and like you said, you're coming up with, I'm going to call this resource, this host, right? So that's just fine. That's pretty much the way to do it at that point. As long as your resource that you're dealing with is the right level of abstraction that you want, that name, that title that you use, you're going to vary that so that you make sure that you're using the right name.
Do you have a question?
Yeah, you mentioned earlier that Puppet does immutable infrastructure.
Mm-hmm.
So I was just kind of wondering how Puppet is doing. Because Puppet is the configuration language, so how does it?
Right. So the agent, say, enforces a configuration. You can make a change. It will get fixed on the next Puppet agent run.
Yeah,
It's not exactly the same. I know what you mean. But I was saying it a little bit of a shorthand way. But eventually, you can enforce things to be in an exact state using Puppet. It's like say, people can change it. Puppet will change it right back. Yeah.
The last statement you made before the question slide, Puppet allows for full state introspection prior to application. What precisely were you referring to? The only thing that makes sense to me is the no-op flag.
RSpec Puppet. There's a tool called RSpec that you can use to basically test that your catalog has the things in it that you expect it to. So you can use that. There's also then there are tools that will let you spin up VMs and apply your your module or whatever, and actually test that the code does what you think it does, right? So there's lots of really cool testing tools that are built around Puppet. And you can run all those tests without ever applying the code to an actual system.
Puppet has a dependency in Java. Do you foresee any changes given the Oracle's licensing change with Java?
I don't know. I don't work for Puppet, so I can't really say a whole lot. But I imagine that OpenJDK is a thing, right? So if I'm pretty sure they're already using OpenJDK for the for running Puppet. But yeah, I don't know. At this point, I don't know if anybody cares what Oracle's doing with Java. To be honest, everybody else is going to move on. I got to wrap up. But if anybody's got any more questions, feel free to let me know. It's my first name last name at onyxpoint.com or gmail.com. If you want to email me, catch me here. Like say my company, the company I work for, Onyx Point, I do consulting and training and all sorts of stuff. So if you want any help with any of that stuff, let me know. And like I said, I have T-shirts. So feel free to come up and grab a T-shirt on your before you head out. So thanks everybody.